Okay, so we're going to talk about radians and central angles. Another way to measure angles is in radians. Radians have no units. One complete circular revolution is 2 pi radians. And 1 radian is equivalent to 57.296 degrees. So we say that 1 revolution is 360 degrees. And that is the same thing as saying 1 revolution is 2 pi. So if we do, let's say we can come up with 360 degrees by the 2 pi radians. So this would be 2 times pi is 3.14159.265 and so on. And if I multiply that together by 2, well, if I multiply 3.14159.265 by 2, I get 6.2831853.071 and so on. So if I multiply that by 1 radian, because 1 radian is 57.296. If I multiply that by 57.296 degrees, I should get, because this is 6.2831853.0 radians. And if I do like a conversion, let's do 6.2831855. I'm gonna stop there. Radians times 57.296 degrees in 1 radian. Let me spread this out. 6.2831855 radian times 57.296 degrees per radians. Then the radians would cancel out, and then I would have I'll have 360 degrees, 360.001 degrees. So 1 revolution, 360 degrees, is equivalent to 2 pi radians. All right, so 360 degrees is equivalent to 2 pi radians. All right, central angles on the unit circle. We use a central angle of a unit circle shown at the left, where the vertex is the center of the circle. 1 radian is the measure of the central angle that subtends, intercepts, an arc equal in length to the radius of the circle. The circumference of any circle is 2 pi r, where r is the radius measure. So the circumference of a unit circle where r equals 1 is 2 pi times 1. Therefore, an angle representing 1 complete revolution of the circle measures 2 pi. Okay, if that sounds confusing, then don't worry about it, because all you need to know is 1 revolution is 360 degrees, which is equivalent to 2 pi radians. All right, so we have some common radian measures at the bottom. It says if theta is a central angle in a circle of radius r, and if theta is measured in radians, then the length s of the intercepted arc is given by s is equal to r theta. So in geometry, you learn how to find the arc length of a circle, and that equation was given by s equals r theta. All right, so common radian measures. It says at the bottom, says sketch each radian measure on the coordinate plane below. So I have negative pi over 4 radians. And what I really want to do is convert the radians to degrees so I can actually sketch the angle on the coordinate plane. So I know that if 2 pi is equal to 360 degrees, then 1 pi has to equal 180 degrees, because if I add 1 pi and 1 pi, I get 2 pi, which is 360 degrees. So I can convert this by saying that pi is equal to 180 divided by 4, and I'll get negative 45. So to sketch negative 45 degrees, again, I start at my vertex with my initial side drawn, and then I'm going clockwise, so I'm going this way. And so my angle would be, this would be negative power 4, which is the same thing as negative 45 degrees. All right, then I have pi over 2. Well, if pi is 180 degrees and I divide that by 2, then I get 90 degrees. So pi over 2 is graph this way. Okay, that's pi over 2, which is 90 degrees graph. And then it says pi radians. Well, I know pi is 180 degrees, so I just need to graph or sketch the graph of 180 degrees. So if I start at the initial side and go this way, this is the graph of 180 degrees here. Okay? Okay, so let's look at a conversion formula. We're going to convert between units of angle measure. So we're going from radians to degrees and degrees to radians. So to convert degrees to radians, we're going to multiply degrees by pi over 180 degrees. To convert from radians to degrees, we're going to multiply radians by 180 over pi. 180 degrees divided by pi. Okay. All right, so it says convert. The example says convert each angle from radians to degrees or from degrees to radians. So I have 7 pi over 6, and I want to convert from radians, because this is in radians, to degrees. So I'm going to actually multiply this by 180 over pi. And what's going to happen is that my radians are going to cancel out. And I'll have 7 times 180 divided by 6. And that's going to give me 210 degrees. All right, I have negative 2 pi over 3. So I'm going to multiply this by 180 over pi. My pi's cancel out, so I have 2 times 180 divided by 3. That's 120, but that's a negative sign in front of the radian, so it's going to be a negative sign also in front of the degree measure. All right, then I have negative 8 pi over 15. I'm going to multiply this by 180 over pi. The pi is going to cancel out, so I have negative 8 times 180 divided by 15. It's going to give me negative 96 degrees. Now, I want to convert 135, negative 320, and negative 110 to degree measure. So, I'm sorry, to radian measure. So, I'm going to multiply 135 by pi over 180 degrees. So, I'm going to get 135 pi over 180, but I need to reduce that to 3 pi over 4. Okay, then I'm going to multiply negative 320 by pi over 180. And remember the degrees cancel out. So I have negative 320 over, negative 320 pi over 180. And if I reduce that fraction, I get negative 16 pi over 19. Over 9, not 19, but 9. All right, and then for negative 110, I'm going to multiply that by pi over 180 degrees, and I get negative 110 degrees over 180 degrees. And that's going to give me negative 11 pi over 18. All right, so we have some more problems at the bottom. It says practice with radians. How many radians is each angle of a an equilateral triangle? How many radians is each angle of an equilateral triangle? So, equilateral triangle, all the angles are 60 degrees. They're the same measure. And remember, the sum of the angles of the triangle add up to 180 degrees. So, if all the angles are 60 degrees, then the number of radians in each angle is going to be 60 degrees. We've got to convert that to radian measure. It's going to be pi over 180 degrees. And that's going to be 60 divided by 180 pi, which reduces to pi over 3. So there are pi over 3 radians in each angle of an equilateral triangle. All right, it says the minute hand of a clock travels how many radians in 15 minutes? All right, so let me read this question. Number 2, the minute hand of a clock travels how many radians in 15 minutes? So this is what I know. I'm going to go up here. I know that that 1 degree is 60 minutes. And if I multiply 15 times 1 divided by 60, I'm going to get, the minutes going to cancel. I'm going to get 15 over 60th of a degree. If I reduce that by 5, I get 3/12 of a degree. And if I reduce that, I get 1/4 of a degree. So, the minute hand of a clock travels how many radians in 15 minutes? It'll be a fourth of 360 degrees. And that's going to give me 90 degrees. So, that answer is going to be 90 degrees, but it wants the radian measure of 90 degrees. Well, if I take 90 and multiply by pi over 180, I'm going to get 90 pi over 180, which is just pi over 2 if I reduce that. All right, the third one says, the minute hand of a clock travels how many radians in 10 minutes? So I have 10 minutes. I'm going to convert that to degree or degrees, and I'm going to get 10 over 60 degree. And that's going to give me 1/6 of a degree. And then I just multiply 1/6 times 360 of a revolution. And I'm going to get 60 degrees. So this would be 60 degrees. But again, we have to change this to a radian measure. So I get 60 pi divided by 180. And that's going to give me pi over 3. Number 4 says the minute hand of a clock travels how many radians in 5 minutes? So again, I need to convert 5 minutes to degrees. So 1 degree is equal to 60 minutes. I'm going to get 5 over 60 degree. That's going to give me 1 over 12 degrees. 1 over 12 degrees. All right, so I am going to multiply that 1/12 by 360 degrees. So that's the same thing as taking 360 and dividing it by 12. And I'm going to get 30 degrees. but I need a radian measure, so I'm going to multiply by pi over 180 degrees, and it's going to give me 30 pi over 180. It's going to give me pi over 6. Okay, so that's how you do those problems. What is the measure of theta? This is number 5. What is the measure of theta in radian measures? Okay. Let's see. All right, so what is the measure of theta in radians if x is 45 degrees? So if this is 45 degrees, okay, wait, I need to get that back. Okay, so if this x is 45 degrees, all right, so, and that's this little part right here, then this big part has to be 360 minus 45. So that's going to give me 315. So the big part, the big measure is 315 degrees. So that's 315 degrees. So, but I need that in radian form. So I would just take 315 multiplied by pi over 180, and I should get 7 pi over 4. Okay, then it says, what is the measure of theta in radians? Well, from the initial side all the way to the terminal side, they're saying that's 5x. And then from the terminal side down to the x-axis, that is x. So if I add both for the angle measures, that's 5x plus x, I get 6x. And remember, from the initial side all the way over to the negative x-axis, that's going to be 180 degrees. So I would take 6x and set it equal to 180 degrees and divide by 6 so I can solve for x. And that's going to give me 30 degrees. And then I would need to convert. Well, the x would be 30. This would be 30 degrees, the smaller angle. And the bigger angle would be 5 times x, which is 30 degrees. And that's going to give me 150 degrees. All right. And then I would take 150 and multiply it by pi over 180 to get the radian measure. And that's going to give, if I reduce that, that gives me 15 pi over 18. Reduce that by 3. I get 5 pi over 6. So my measure of angle theta is 5 pi over 6. Okay. So that's this answer, and then that's the answer to this. Okay.